Good morning, students. My name is Dr. Tushar De, and today we will discuss about Bohr atomic theory. Bohr atomic theory. So, most of you know about Rutherford atomic model. Rutherford established an atomic model based on his gold foil experiment, and from this model we can conclude that, or Rutherford concluded that, most of the space in an atom is empty and most of the mass and total positive charge of an atom is present at the nucleus. This is where proton and neutron is present. But there are certain limitations of Rutherford atomic theory. Bohr atomic theory overcomes the limitation of Rutherford's atomic theory. The major limitation of Rutherford atomic theory is that Rutherford did not specify the orbit where electron is revolving. Rutherford only told that electrons are revolving around the nucleus in some circular path which is known as orbit. But there may be many number of orbits such as K, L, M, N, O, P, Q, etc. But Rutherford did not specify any particular orbit where electron is revolving, but Bohr specified the particular orbit for an electron. According to Bohr atomic theory, the first postulate is like that the electron cannot revolve in any orbit. Okay, the electron cannot revolve in any orbit. There are some certain orbit. So Bohr told that electron will revolve in such a orbit where the angular momentum of the electron will be an integral of h by 2 pi. So this is the postulate of Bohr atomic theory. So what is the postulate? We have to discuss about it. Suppose the mass of electron m velocity of the electron in a particular orbit is v, and radius of the orbit where the electron is revolving equals to r. So the angular momentum of the electron, will be mass into velocity into radius. Bohr told that if an electron is revolving in an orbit which radius is r, then the angular momentum mvr will be an integral multiple of h by 2 pi. So what is the significance of h? H is the Planck's constant. H is known as Planck's constant. It has some specified value which is equals to 6.626 into 10 to the power minus 34 joule second in SI unit, and in CGS unit it will be 6.626 into 10 to the power minus 27 arc second, CGS. So this is the value of Planck's constant, and you know about the value of pi equals to 22 by 7. So the term h by 2 pi, is a constant, right? H by 2 pi has some specified value which will be, so what is the value of h by 2 pi? It will be 6.626 into 10 to the power minus 34 by 2 into 22 by 7. So what is the significance of n? N is the cell number or principal quantum number. N equals to cell number. For example, there are 7 cells K, L, M, N, O, P, Q. So the value of n will be for K cell 1, for L cell 2, for M cell 3, for N cell 4, for O it is 5, 6 for P and 7 for Q. So this is the value of n. Okay. So every electron must have some specific angular momentum. How? Suppose an electron is moving in M cell. Suppose an electron is revolving M cell, right? An electron is revolving in M cell. So what will be the value of n? The value of n equals to 3 for M cell. So what will be the value of angular momentum? So mvr, which is equal to angular momentum, will be 3 into h by 2 pi equals to 3 into 6.626 into 10 to the power minus 34 joule second by 2 into 22 by 7. So these have some specific value. From this value, if the mass of electron is known, we know the mass of electron, and if the velocity of the electron is known in the particular cell, then we can easily calculate the value of radius r. So if an electron is revolving in a particular cell whose radius is r, then its angular momentum is fixed. Okay, and this is called quantized. This is called quantized because angular momentum has some certain values. For example, for K cell, the angular momentum will be h by 2 pi as the value of n equals to 1. For L cell, the value of angular momentum will be 2h by 2 pi equals to h by pi. For M cell, it will be 3h by 2 pi. So for every cell, electron has some certain angular momentum. Okay, and any value of angular momentum is not possible. Okay, if the angular momentum is h by 2 pi, then the electron is revolving in K cell. If the angular momentum is h by pi, then the electron is revolving in L cell. And if the angular momentum is 3h by 2 pi, then the electron is revolving in M cell. So every electron has some definite angular momentum. This is called quantized value. Okay. So this is called quantized value, right? So this was about the first postulate of Bohr atomic theory. Also the second postulate of Bohr atomic theory is based on the another drawback of Rutherford atomic model. According to Maxwell, in Rutherford atomic model, when an electron is revolving around the nucleus, it can lose some energy. So the radius of the orbit will be decreased, and once a time electron will jump in the nucleus. But according to the Bohr theory, this is not possible. An electron does not lose any energy when it is revolving around a nucleus in a particular orbit. So what is the postulate? An electron never does not lose any energy when it is revolving around the nucleus in a particular cell. But according to Maxwell, in Rutherford atomic model, an electron may lose its energy because their classical mechanics is applied. But according to Bohr, as the electron is a subatomic particle, also electron, proton, neutrons are subatomic particle, so they will not follow any classical mechanics law. Any law of classical mechanics will not be applied in the subatomic particles. So electron will never lose its energy. Okay. Third point. When an electron absorbs some external energy, suppose we are hitting a metallic wire, so what will happen? The electrons present in the metallic wire will absorb this energy, and after absorbing this energy, the electron will be promoted to next higher cell. At first we have to draw an atomic structure. Okay, at first we have to draw an atomic structure, but before drawing this I am writing the third postulate. If some external energy will supplied, electron will absorb this energy and will be promoted to next higher energy cell. You have to know that when we go far from the nucleus, the energy of the cell increases. Okay, so I have to draw an atomic structure. So this is the nucleus. This is the nucleus where proton and neutron is present. Okay, and now I am drawing different cells. So this one is K cell. Okay, this is L cell. This is M cell. Okay, and this one is N cell. Okay. So this is K cell, this is L cell, this one is M cell, and the last one is N cell. So suppose an electron is present in K cell. So if you supply some energy from the external source, the electron present at the K cell will absorb this energy and immediately promoted to next higher cell. It may be L, M, N, any cell. Okay, according to the amount of energy supplied or according to the energy absorbed, the electron will be supplied to next higher cell. It may be L, M, N. But after promoting to the next higher energy cell, the electron will come back again instantly to its original cell by releasing some energy in the form of wave. Okay, if the wavelength of the energy or if the wavelength of the wave lies between visible range, then we can observe some visible color. For example, if we heat some hydrogen gas or if we excite some hydrogen gas by creating a high voltage difference, you can see that hydrogen gas becomes red in color. Okay, why? Because the electrons present in the K cell of hydrogen atom is accepting this external energy and is promoting to next higher energy cell. And again, instantly, the electron is coming back to its original K cell by releasing the energy in the form of wave. And the wavelength of this energy radiated lies between the red color wavelength, which is around 6500 angstrom. Okay, that's why we can see a red color. Okay, Also, there is an important fact about this structure. Suppose this is U1, energy of K cell is U1, energy of L cell is E2, energy of M cell is E3, and the energy of last cell E4. So we can write that E4 is greater than E3, greater than E2, greater than E1. As we move from the nucleus, the energy will increase, but here you can see that the energy gap decreases. What is the energy gap between K and L cell? It will be E2 minus E1, right? The energy gap between K and L cell is E2 minus E1, and the energy gap between L and M cell is E3 minus E2. From this figure, you can easily observe that E2 minus E1 is greater than E3 minus E2, and E3 minus E2 is greater than E4 minus E3. So as we move from the nucleus, the energy of the cell increases, but the energy gap decreases. Okay, but the energy gap decreases. For suppose the energy of K cell is 20 unit, the energy of L cell is 60 unit, the energy of M cell is 80 unit, and the energy of N cell is 90 unit. So what is the difference between energy of K and L cell? 40 unit. The difference between L and M cell, 20 unit, and the difference of energy between M and N cell is 10 unit. So the energy increases, but the energy gap decreases. Okay, so that's why E2 minus E1 is greater than E3 minus E2, greater than E4 minus E3, right? And what is the last postulate? According to Bohr theory, if an electron releases del E amount of energy, which will be equal to difference between two successive level or any successive energy levels, then delta E will be equals to hc by lambda. If an electron releases del E amount of energy, okay, when coming back from higher energy cell to lower energy cell, then delta E equals to hc by lambda. Here h is again Planck's constant, c is the speed of light, which is 3 into 10 to the power 8 meter per second, and lambda is the wavelength of the energy radiated. There are different units of wavelength. For example, we can use angstrom, we can use nanometer. For example, 1 angstrom is equal to 10 to the power minus 10 meter, and 1 nanometer equals to 10 to the power minus 9 meter. So you have to know about the different units of the wavelengths. Okay, so this was about the Bohr atomic theory, and there are some limitations, there are major limitations of Bohr atomic theory. But before learning the limitations of the Bohr atomic theory, we have to know about the spectrum: absorption spectrum, emission spectrum, continuous spectrum, discontinuous spectrum. So for today, this was our class. So thank you. Hope this will help you to improve your knowledge. Thank you.